Let's see this. Number of perfect matchings in a complete graph. So you are supposed to find out how many perfect matchings are there in a perfect graph. First thing is, in a complete graph. So first thing is, if the graph is containing odd number of vertices, there will never be any perfect matching. The reason is, if you are going to take the edges in such a way that the vertices there should not be any common vertices between these edges, then there should always be even number of vertices. Otherwise we cannot choose. Let's say you have chosen k edges, and now if you want this to become a perfect matching, then these k edges should definitely cover, or will definitely cover 2 into k vertices, right? Which means the matching will always cover or always saturate 2k vertices, right? It can never saturate 2k plus 1 vertices. Got it? So if you have to saturate 2k plus 1, it means that you have to include one vertex and a edge on that vertex, and since our matching does not contain any loop, we can never get that. Got it? Okay, so k2n plus 1 has no perfect matching, which means a complete graph with odd number of vertices will never have a perfect matching. There will be always one vertex left out. And next one is the number f of n of so let us assume that we want the number of perfect matchings. The number of perfect matchings in k2n is the number of ways we can pair up 2n distinct people, right? So this one can be correlated that way. Now one thing is, in k2n plus 1 we found out that there can be no perfect matching, but then if there are even number of edges in a complete graph, then there can be perfect matching. Now this problem can be compared as if there are a group of 2n people, and now we want to pair up them into pairs. We want to make them into pairs in such a way that I want to get n pairs, right? So that is the problem here. So this problem can be treated as if there are 2n people, and now we want to pair 2 people each, and we want to get n such pairs. Okay, so how to do it is, watch it. Now for the first person, so let us say there are 2n. Now for the first person, out of this 2n minus 1 people, he can choose any one, isn't it? So for the first person, he is having 2n minus 1 choices. Now let us say one of them is chosen. Therefore for the first one, 2n minus 1 choices, one of them is chosen. Then what happens is, this first person along with the chosen person should not participate in the next matching again, so they will be removed. Now how many people will be remaining? 2n minus 2 people will be remaining, right? So out of those 2n minus 2 people, I'll choose one more person. Now for that selected person, we are going to have 2n minus 3 choices. Are you getting this? When I had only 2n people, and when I had chosen one person, he was initially having 2n minus 1 choices to select a pair. Now once that choice is made, these 2 people cannot participate in the next matching, therefore they have to be removed. Now how many people will be remaining? 2n minus 2 people will be remaining, out of which if I pull out 1, then the number of remaining people will be 2n minus 3. Therefore for this person, the number of choices he will be having is 2n minus 3, right? So for the second one, 2n minus 3, right? Now let us say I had made a choice. Now how many people will go out? 2 already left. Now 2 are leaving. Therefore how many will be remaining? 2n minus 4. Now out of this 2n minus 4, if I pull out one of them, then how many will be remaining in this group? 2n minus 5. Therefore for this person there are 2n minus 5 choices, right? So 2n minus 5, so on 1. So this is the answer. So this is the number of ways we can pair up 2n people into pairs of 2 people each. This is one way. And what is the other way is, you can list down all the people. So you can find out 1 2 3 4 5 6 7 8 so on to n. You can order all these people in 2n factorial ways, right? Now once you write down the order, you can actually pair them by taking first two, next two, next two, and we can do it like this, and last two, right? Now the problem with this is, with this kind of ordering is, I might get more such orderings than the actual number of matchings possible, or the same matching will be represented in more than one way in this order. Why? Because I'll get one ordering this way, and the other ordering will be containing all the ordered paid as it is, but their orders will be, the way in which, the order in which they appear, the order in which these order pairs appear will be different, right? Therefore, for every matching, actual matching in this list, I'll be getting n factorial times, as well as inside each one also, instead of 1 2, I'll get 2 1, so 2. Are you getting this? Even though the total number of matchings are less, in this ordering method, I will be getting a total of 2 power n into n factorial more. So why this factor more is, one is, many of the orderings will represent the same matching, given that if you know how to rearrange these ordered pairs, and also within the ordered pair I can rewrite these two. So instead of 1 2 I can write 2 1, instead of 3 4 I can write 4 3. Therefore each one is actually generating these many more sequences, right? Now if I have to reduce them all, so out of this 2 power n factorial, if I have to eliminate all the duplicates, then I have to divide it with n factorial into 2 power n. I hope you understood why this factor in the denominator. One way is I am going to get many possibilities because of the rearranging of this, and second thing is I am going to get many possibilities because of the rearranging of the terms within the ordered pair. Got it? Okay, so this expression and this expression both are one and the same, so you can prove that these two are having the same value. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.